Hi, for those who don't know me, I'm Quentin ADAM. I'm the CEO of a company called CleverCloud, and I'm basically everywhere on Twitter, GitHub as WAXZCA. Um, this is my day-to-day work. In fact, at CleverCloud, we're making something we call the platform as a service. So the platform as a service is something where you push your application, and then we deploy it with a downtime. We make the security, we watch if it fails, we are able to upscale on those scaled application like automatically. It's pretty cool, and we have a lot of developers using it from 60 countries now. So we see big companies, small startups, things like that, making a lot of projects on top of CleverCloud. And we learn a lot about what is a bad design, what is a good practice, what is a bad practice. So we learn about how developer works, and we try to push back to the community because we have a very interesting point of view on that, and we push back to the community. So basically, I want to speak with you about an industry. The industry of software is quite young because it's a very big game changer. But if you think about it, we have 30 to 40 years old. So it's a very young industry with nothing built right now. We're just at the beginning of something. And we are growing from nothing to billion-dollar company and at an impressive market. If you are looking at the world today, nobody thinks the world can be the world it is without Google, Apple, Netflix, Pornhub, I don't know. But the thing is how we work, because we're still young, and we don't take the time to think, okay, how we make our work of software industry, and what will be the next 20 years of the evolution. For this, I want to speak with you about the mankind evolution. If you think about this, the mankind is evolving right now, and there is something happening called the law of accelerating returns. What is the law of accelerating returns? The law of accelerating returns say one step on technological progress made the next step easiest to make. So basically, at the beginning, we start to create fire, and that hundreds of years later, we start to have cool tools to just kill animals. And this technology path is becoming faster and faster, and the acceleration of the progress in technical things is something quite interesting, because we do all the things to make our life more comfortable for us. So basically, we are the people to build our world like what we want to do, and be able to manage a population growth, because there is a lot more human on the planet this century than 2 centuries ago. So we are in a growth in accelerating progress and accelerating population. And this is why we are creating tools. At the beginning, we are creating tools to enhance the production, because we need to achieve the production industrialized. So this is what we do at the 19th centuries. At the 19th centuries, we have achieved to create an industrialized way to make tools, to make things. And what is an industry? If you think about it, an industry is a cost-efficient way to produce large volume. At the beginning, making books was handcrafted, and people are copying books. Then we built the whole industry of the printing. Then books in production was a scale. And this is the way we create repeatable and scalable process to manage this, like, for example, unbottling beer. We have to bring this kind of thing. And achieving that, we create a commodity. If you think about this, no, this is a commodity. But 2 centuries ago, writing something was a handcrafted method for everything. No, when we need to write something, we think a pen. A pen is a commodity. There is this pen and another pen, it's nothing. We just want a pen. It's basically a commodity. And that's why all the 19th century was doing to making something about manufacturing things. And it was allowed by the engine. Because at the beginning we create the engine, which is basically a mechanical Turk able to manage all the workforce of a human. But if you think about this kind of thing, no, we have the computer. And the computer is basically a very efficient tool to industrialize the brain power of a human. So basically, it's the engine for the intellectual services commoditization and industrialization. So I think we are in an era of industrial revolution, just like the 19th centuries, but for brain power. I give you some example because I know some people are not agree with the terms of industrialized and workforce like brain power. If you think of the job of comparing price, just 25 years ago, in a company was guys taking all the price list and comparing the price and by hand and doing this kind of stuff. If you are doing about the math, at the beginning, we have no tools for making the math and people are just calculating by hand. And what about the accountment in company? 25 years ago, it was like plenty of people doing the math about all the companies making money. And right now, we have Excel. So basically, we have industrialized the brain power, all this kind of stuff. And it's quite interesting to see, because it can go beyond next to the translation, the image recognition. I don't know if you know this kind of stuff, but 4 years from now, each 0.01% of translation of image recognition rightness was about a lot of work for people. But right now, we have something we call machine learning with neural network. And they're taking about 5% enhancement per year. So it's something like craziness. So it's bigger and bigger. And this is our job. So that's why I want to speak with you about developer. Developers are the maker of the tools. And these tools is basically creating power tools to industrialize the brain power. And in an economic world, managing the human activity there, it's tools for improving the business, the life, maybe the world, and we are able to do that because we understand the process to create value. So basically, the developers are the people we know the process to understand how to create money. And this is why some big startups are disrupting markets, if you think at Uber, Google, and this kind of thing. Because software is eating the world. Software is eating the world is an expression from a guy called Ben Horowitz. Is one of the most known venture capital in the valley, and is creating this kind of thing to saying, so software is industrialized the brain power of the world. Then the developer manage more and more important for the business. And they rule the business. So if you think about it, some years ago, software was an investment. Investment like the V process. I give you how to make a software and what is the mission, and you have to write the software, and at the end, I get the software, and it's a tools, and I make like an accountment, like it's an investment for years, like a powering machine tools for an industry or a factory, if you think about it. But the thing, it's like creating assets like real estate. It was just like we create a tools and we will have it like an assets for years. But we know really what's going on today. Software is a services because it's a continuous delivery asset services, we provide a better way and a better way to enhance the business of the company. And this is a constant improvement system. We create a process, and some other people are creating low-level plumbery tools to make this happening and working. And we can improve there and continually improve the industrial tool assets to making the factory working better and better over the time. This is quite cool because it's act on data. And if you think about this, we as developer, we are managing data process and data management. In fact, we're creating a data pipe able to manage the data and make some operation on top of it. I don't know if you know this, but this is part of the source code based on Hakka stream system. So all the reactive stream stuff based on the JVM. And this is if we say you have a source of data. We have an output for the data. And then we will make a flow with it. So I take the data, I put it with an arrow in this process, then we broadcast the data to two other processes. They will make some operation there, then merge the data, then put in another process and output the data there. So basically, today, the technology allows us to create real data flow. It's no more like complicated things like we make buffer theme transition for the streaming stuff like we're making Plumberry before. It's more like, okay, just make a data flow and improve the business around this data. So we can become architect of a business factory. And we are not the blue worker anymore. We are the people who decide how to make more business with a software because it's a powering tool of brain power. So we need to connect the business or the vision, and developer is no longer a job, it's a point of view. We are builder of tools, and we can build this kind of stuff around that. And it's a skill of business architect. So basically, this is the thing. Okay, we have creating system like software, and around the software, we have creating framework because it's an automatization of things. At before, we're writing the software all around, then library, then framework to automate that and make them more standard. Then we have creating build tools to be able to reproduce the software when we want at any time and put it in a source management system and connect this with a continuous integration. So right now we can run tests and things like that to be able to make sure the continuous integration of the software is building on. And it's a fully automated software factory. From my point of view, it's an industry. It's cool. And then we take all this software factory output and put it on a server. Like a server. Like, we know, we take a server like hardware and we put it an operating system on top of it. Cool. And we can run middleware and software and things like that. And we create a monitoring policy with some backups policy, and it's specific to each project. And do you think it's an industry? It's not like this because we're building uncrafted special things for all the thing. Okay, you can say to me there is cloud, there is infrastructure as a service. Yeah, cool. You can use a virtual server, but if you think about it, you have still some manual tasks to perform. It's not fully automated. It's not pluggable. You cannot just say, okay, let's move from Amazon to the bare metal to Azure and don't know, because you have some tasks to perform. You have to SSH connection, going into Tmux, launching your software, all this kind of stuff. It's not like electricity. Think about this. At the beginning of the 20th centuries, people are starting to use electricity in a factory process. And the thing about that is they have their own electricity production. And what is going on is the production line was poisoning the electricity, was poisoned by the electricity production because people are making the electricity, like for example, running a road in the water, and it was creating like specific electricity things like 73 continuous voltage. What we can do with that? The problem is all the engine you put behind are to be able to be working with this kind of stuff. So you have to manage all the things for your production right to be like unstandard, because you have to make this. And you have a deep dependency linking between all of this, because we cannot create an ecosystem around that. If you think about today, and at this time they was doing there, all the people on this industry were just like, no, we cannot centralize on making the electricity. You know, we have engineers making that for, I don't know, 20 years and working pretty well. We have sometimes like 18% not on time, so it's okay. Buy electricity today, you're not buying a power plant. You're buying electricity as a commodity. Never of one of you are thinking, okay, am I building something on electricity around 21 alternative voltage? No. You just have electricity. It's a standard way. It's a commodity today. And nobody have an electricity project. Just think about that. Electricity project. I want to put a TV screen on my office. Can I have an electricity project to be able to power it? But basically, it's what people do with hosting project, because it's always specifics. And there is no industrial way to think about this. And Ops today is making tailored things made by people, and yeah, we will manage it like people by people. So basically, wake up. If you think about it, production has to be perfect. With no downtime, you have to be working all the time. And the humanity is not perfect. A human can be perfect. So if there is people managing servers in production, we have a problem, because it cannot be achieved to be perfect. If you think about it, what we need to manage a production is just bots, like Ultron. It has to be like perfectly stupid, like a robot, because we have to achieve 100% uptime ability. If you think about it, at Clever Cloud, this is a red alert to have someone with SSH connection in a virtual machine, or not virtual machine, by the way, because it's something like there is a user in production. It's not made for human. It's the land of the bot. We don't have to achieve that like this. So we need to build hosting platform. And hosting platform is a standard way to host software without thinking about this. It's basically commoditization of the software. And there is no place for hubs. Just platform manager. We have to change all the thing about how is made hosting today. Because what is a platform? A platform is basically the hardware, the software, and the service all together, and able to give to the developer something simple, like the developer do git push. Developers are here to work on code. They building the code, then it's no more their issues. They git push on firmware, and it's not their job to managing it online. There is too much work to do. As a developer, you have to building the business factory, not keeping electricity up. Applications have to deploy automatically without downtime, because developers have to be able to push new version in production when they want. They are creating business. They are not thinking, okay, can I do a maintenance? I don't know without this. If you have continuous deployment, why we can schedule the maintenance? You have to be able to push new version of software like 60 times a day. It's okay. We have the technology to doing that today. And we can use the build system, or maybe Docker as an operating system builder. So there is plenty of tools to do that, and to be able to manage all the things like upscaling, down scaling, And this is the job of the platform. This is not the job of the developer to go on the Amazon console or say, okay, I want to start 2 VMs like more, and no, we don't use it anymore, we don't scale it. Because at scaling have to be done saying, okay, we have a team of superhero working on our application, and you have to be a relaunch and failure. Why people are making monitoring? The monitoring is saying the application is down and there is a guy connect to a server to restart the application. If a computer knows the application is down, it can relaunch the application from himself. It's not have the job of a guy reading emails and saying, okay, I have to restart it. It's nonsense. It's just like stupidity. And all the backup policy thing, like, yeah, sure, we will backup. So there is standard backup policy. We make backup. We don't have to think, okay, what is a backup policy for this application? I don't know. We don't care about the data, just trash it. There is only one people saying that to you once? No, backup policy is simple. We need this data and we can't lose it. So backup it. No backup policy more. And that security. Security is something I really like. For 15 years, people have think if the code is old and well tested, it cannot break. Sure. All the last year's failure and all the last year problem on security was just corrected on the code for years. And the Linux distribution saying, oh, I'm not sure I can make an update on the glibc. Yeah, guys, make the update on the glibc. There is flow, security flow on the glibc. Just fix it by pushing update on production. Today, we need to stick at the code level more recent, because the code level more recent is the code level where people are thinking big. And this is a totally new way to think the security. Why? Because security is a full-time job. You have to read all the security flow going on internet. Do you know that major security flow per year is about 6,000? Not like 3 or 4 like we can see in the media. It's something like 6,000. So there is plenty of job to do. And it has to be maintained by the guy who called the platform manager. And the platform manager is a guy able to manage a lot of servers. If you think about this, at Facebook, there is one technician in the data center for 25,000 servers. The basically classic hosting services is about 200 servers per people. This is industry. This is how we can manage to do things like at large scale production volume. And this is the right way to do it. And if you have to think it as a developer, it's not your job. Your job is to creating the business factory, not to creating the electricity. It's the same thing if you say to the guy at Samsung creating TV screen, okay, how we can make electricity for that, and can you monitor what is doing the power plant in France? The guy will be looking at you like, it's nonsense, guy. If you think like this as electricity, it's the end of server management, because it's respecting commodity standards. When you're installing a new TV screen, you're not calling people from the power plant saying, okay, I will launch my TV right now, so maybe I will eat a little bit more of electricity. There is no need of communication between the kind of people, because it's totally different job, because it's based on a commodity and standards. So we need to work like an industry and building a scalable production line for industrial and intellectual services. Okay, for this, there is some architectural insight. First, one server, virtual or not, have just only one task. Because if you split many tasks at the thing, it creates like complex thing to think about this. And all the application you build are able to make it at cluster. Because clustering and the ability to scale out is not only for huge load, it can only be used for making your application restart without downtime. Because if you have your application A on version 1 running there, we start the application on version 2, okay, it's working well. We just send the flow of the networking on the application on version 2, and then kills the application on version 1. So that's why it's, and if you have just a small application with just few people, during few seconds, the two applications have been started in the same time. If your application can handle this, you have a problem. Because you will not really being able to restart without downtime. And for thinking about this is the statelessness is the key. You have to think at your application instance like clone, and you can kill a clone, take another, it's no matter. You are in a statelessness world. This is quite important to think about it, because it prevents you to making mistakes. For years, people at operating system are thinking about Olympic contest of uptime. Yeah, we have a servers. It's running for 11 years. Oh God, it's running for 11 years. So we haven't been patched in 11 years. Congrats. Do you know one software who haven't been in the security flow for 11 years? It's not happening. At Clever Cloud, what we think is if a server, and a virtual server or hardware server, have been booted for more than 5 days, there is probably a problem. Because it's old, and it's generation, and you have to make all the compatibility of this kind of thing. Because you have to think as clusterable application. The ability is to say we're templating OS. So the operating system is a template. We build the application on top of it. There is no maintenance. I will not take a template and saying I will update the virtual machine system. No. The virtual machine system is running, then it's killing, replacing by a younger version of the template, a newer version of the template. We never take maintenance inside the operating system. We don't need packet manager, compilation, all this kind of thing, which is pretty weird because we just want one state of a virtual machine. So the only state is running. If it's not running, we kill it and replace it with something running. Do you understand this kind of thing? And it can allow you to decreasing the tooling of the server. If you think about it, securing a packet manager to managing the way to update the servers, it's quite complicated. And better, if you securing something like the Linux kernel to be able to be rebooted, not rebooted, but updating where it's running, it means that you can take a code and make it run on the root land of the kernel and the kernel land of the CPU. And basically, is a kind of security flow. If you look at the major security flow of the kernel the past 10 years, more than half was based on module insertion. If you create immutable operating system, you don't need module insertion, so you deactivate it in the kernel, and you are able to managing only new operating system every day, and monolithic kernel. So you build something more stable, and you build something more secureable, because you kill some security flow. And you are able to rebuild the whole infrastructure because of that. And you never build legacy system. If there is no more old server and old is younger than 5 days, there is no more legacy system. And legacy system is, I don't know how it works, Maybe it works like that. There is no documentation about that. This is all this kind of stuff, legacy system. So we need to reach something we call immutable infrastructure. An immutable infrastructure is the way that all the servers have a precise task, and we don't need to change the state of a server. A server able to serve web requests is always doing the same thing because it's stateless. So basically, for example, we don't use the file system as a data store. So please stop using the file system as a data store. A file system is something POSIX and ACID. So basically, file system at large scale able to maintain the acidity of the system and all this kind of thing are just unicorns. It's never exist. What we can do is storing technology by technology. So you have to choose the right data store for your kind of thing and think in an architectural way, what is the kind of data you store? Then you take your code and split it in modules. Why microservices approach are cool? Because if you split your code in modules, there is smallest code base, you can deploy a service for each other part of the code and focus on the best technology for a problem. If you have a small code base, it's very simple to see if there is a bug or not, because it's more predictable, because it's simple to read the whole source code. And the whole module are viewed as a service, and others as a client of the service. It's way more consistent and predictable. You have to think all the things like to be consistent and predictable. For example, if your application have monitoring about how many times all the HTTP query takes, if your all HTTP query are taking the same times every time, it's very easy to monitor, because if there is 20% increasing, we know if there is a problem of huge load or something like that. And if there is a decreasing, we know there is a problem. Maybe you're just answering an error, but you don't catch it. Maybe you cannot connect to the database. Maybe there is a flow on network, so you cannot achieve to manage all your connection. I don't know. But if you are very consistent and predictable in that way, it's okay. If your server are making connections for many kind of work, because it's handling the home page, which is basically in a cage, but also the profile settings, and download all the data I have in my time, which is basically a quite long request. All your request time are just making this all the time. So basically, the monitoring have to be like, okay, it takes more than 300% or and 2% of the requests, there is a problem, which is way more non-predictable thing. So if you want to be precise, you have to be consistent and predictable, because we are here to let in the software decide what we want to do. Then, if you make good models, you are able to choose the best tool to solve your problem. If you know there is a library in Node.js application, we're making just the thing you want, you can use it, because it's the best tools. And all the code base can be in Java. If the best way to do it is the Node.js, you can use it. It's modules. You're just taking one module to make this. And it's able to scale your team, because your team is just handling small modules. So they haven't to speak about a big monolithic application, which is quite complicated to handle as a team, but just speaking to each other to making good modules inside of it. The other thing about that is the power to rewrite everything. Rewrite everything is something cool. If we are getting a long time in a code base, we start to making mistakes, and we learn about these mistakes and all that's going on. The other thing about rewrite everything is developer likes it. It's exciting to rewrite all the thing. And if you think about that, you can have a small code base with multiple technology, so kill the legacy. Because if you have a small code base, you are able to say it will not take a long time to rewrite all the thing, because in these modules, what we built is some piece of shit. And rewrite is very quick, because you know all the problem. There is a software inside the Clever Cloud. We take 1.5 years to create it, to build it. And we're working a lot on this software. And after all this time, we put it in production for months, and it was like a nightmare. Crash, inconsistency of the data, problem, handling, and all the ops people are just like, oh God, it's so unstable, it's so bad. Yeah, why? Because when we create it, we choose the wrong choice at the beginning because we don't have the big picture of what we do. And we have lots of problems during the development, so we made a lot of compromise, and the result was not good. But we know the story, and it's not a so big place. So one day, one of the developers said, okay, it's all crap, I will rewrite everything. Within another technology, which is basically more accurate to do this kind of thing. It takes only 3 days to rebuild the whole thing, and now it's working on production like perfectly. Why? Because he knows the problem just before. We are not developer making lines of code. We are not paying by lines of code. We are developer solving problem with industrial way to manage it. And this is why it's not writing the code the problem, is understand the process, managing to industrialize the process and making something cool. The other thing about all of this is splits, process, and storage. You can have your custom code running on something making the storage. Storage of to making all the user input as a data. Event, file, session, all this kind of thing are also data. So basically, if you think about this all as data, you have data qualification. And the data qualification allow you to use multiple databases and middleware to manage your things. So basically, if you have a file, just store it in an object storage, like for example, Amazon S3 or another object storage. If you have a relational data, use a fucking traditional SQL database, which is working very well. If you're handling a lot of documents with the need of searching inside it, with a text managing thing, okay, use Elasticsearch, it's working very well. And each time you have a new data process, just use the right tools to do that. Use a good middleware to handle that. And trust the middleware you use. All middleware comes with checkbox saying, I manage that, and not that. Because there is use case for everything. Just choose a good middleware at each time. And it's better to have the good learn curve about something that's using something which is not made for what we don't. For example, where there is some event on job scheduling inside your application, use an event broker. Like RabbitMQ, SQS, I don't know, Redis if you want, but use this kind of tools, because this kind of tools allow you to decouple an event of the worker from everything. So, and you can bring all the statelessness thing I was speaking about like few slides ago. Then, build a tracking bug and get metrics. All your logs are to be sent to a centralized way to managing logs. All the metrics have to be sent in a monitoring system, because when you have a problem, you need this kind of thing. Just taking the time to have the right tools to managing your problem, it will be a time saver for another day. And be careful about using the dark magic. When you don't understand how is working a framework or a technology, you are pretty well using dark high-level magic. If you don't know how is it working, maybe you will create something who don't build for these tools. You know, several times ago, inside the Clever Cloud, we have a problem with a customer of long time response HTTP requests. You have plenty of requests inside the SQL database and say you cannot scale. Okay, cool, I will managing a cache. And while managing a cache with a library it doesn't understand. So basically, he had about 8 frontal worker, and all the thing the library was doing was creating a SQLite DB shared on NFS file system to making the cache. So basically, it was slowed down his application like a nightmare. Because he was using dark magic he doesn't understand. Just try to understand how technology is working on the bit side. And try to use a technology for the good reason. Because, okay, I will not .js and Mongo for your project. But what is a project? The thing is, you have to choose the technology fitting your needs. And a technology fitting your needs is maybe a technology you don't know. But the learn curve or using the right tools instead of create a monster, it's just a far better thing. Because this monster is basically trying to put, I don't know, try to cook a pizza with a fryer machine. It cannot work. And the pizza will be disgusting. Try to build the good thing with the right tools and not creating monster. And give a try to technology. There is a lot of people around me saying, yeah, I don't know why you are not using Docker for creating the Clever Cloud. Do you use Docker once? Do you have read the code of Docker? Do you have launched Docker inside just your laptop? No, but everybody is speaking about Docker. Yeah, but it don't fit all needs, which is basically quite complicated instead of, in terms of performances and security. And I'm not here to discuss about that, but people just read articles made by tech journalists which doesn't get how it's working the technology and saying, okay, you have to make your choice on that. No, give a try to technology. If you want to use PostgreSQL and never have try, don't put your time to install PostgreSQL in your laptop. There is plenty of PostgreSQL as a service on the internet. And it's free, so go for it. This kind of tools is cool. Just make try of technology in the way you want to try it. And focus on your added value. Because today, some people are saying to you, yeah, a developer will be the developer, the business architect, and the ops because, you know, it's DevOps, so we can manage all the things. No, it's false. Developer making ops is just a developer with constraints on its time at the weekend. You cannot make specialization and making great stuff on your job if you're making the jobs of every people. We need to work as an industry, and making an industry is saying we build specialization and standards are passing the job from one specialist to another specialist. So it's a good thing to work like this. If you think about it, people who say, okay, use Docker and making DevOps, there is 25% of the latest official Docker image built in with a security flow like module, like Ghost. Because it's not their job to update the thing. Making a developer job, a security people, an ops job, or I don't know what, is not the same thing. If you're going to the people making nuclear power plant, it's not the same people who are creating the nuclear power plant, who are selling the nuclear power plant, to monitoring the nuclear power plant and creating the security around the nuclear power plant. So it's specialization, and people are making what they can do with their own added value. Because developers are everywhere. And what I was thinking is, today there is an economic war out there. And the economic war out there is about how we can industrialize brain power. So basically what I think is we need developers to rule all the Fortune 500 companies. So, thank you very much for listening me for this long shot, and we have time for questions. Thank you. Yeah. So I'm repeating for the video. The question is about how to manage a persistence. The persistence is able to be managed at several layers. At the first time, as a developer, I think that is not your job to managing like the database server. You have to take a Redis as a service, a PostgreSQL as a service, a S3 management file as a service. It has to be completely like, for you, it just, I have a database. And all the backups, the monitoring, the security have to be managed out there. As an operating system, how we can manage this? The first thing is in mainly case, we build a huge a huge object storage for hard drive, which is basically a clustering of data. There is some technology interesting to do that, like ROSOFS, Ceph, iSCSI. There is proprietary technology built by hardware providers too. And we export this as just bunch of data storage system. And what we do is basically, at Clever Cloud, what we do is we create a replication at local way to be able to be more efficient in sending the thing. And we can mount all the data from another point. This is one way. Another way is to think you will be using a database able to lose some of the replication thing. Basically, if you're using Cassandra or React, you can lose like a quite good portion of the hardware running your instances before it will be a problem. So basically, in this kind of thing, just we at Clever Cloud thinking it's a better way to just building all on bare metal and managing all around the world. But at some point, there is always a thing. If you need something with acidity and relational database and you use PostgreSQL, you have to be aware of something. There is a single point of failure. But it's way more simple than using something like, I don't know, Cassandra, which is basically without a point of failure, but it can be complicated to work at the beginning. So it's a balance in your choice. And you can change your mind at the time. For example, at Clever Cloud, we have a project handling like a lot of data. And the quantity of data grabbed by this thing on the time is growing. So, but at the beginning of the project, we haven't the time to managing it like a Kafka system because it was too expensive to create the time of the Kafka system. So basically, the decision was the next. At the beginning, we are in a big PostgreSQL handling all the huge load. When the load for the PostgreSQL as it's now will be too much, we will replace all the hard drive with SSD hard drive and make a bigger hardware system for the thing. So it will buy us 3 to 4 months. And then, at the time we need to do that, we know we need to rewrite all the thing on top of Kafka. But we have 3 months to do that. It's manageable. So this is the time of thing you can, it's a kind of trade-off you can do. Because you know, okay, I know it's a time bomb. But when the time bomb starts to tick, okay, I will manage it. And you can make this kind of trade-off because it's clever, because you're winning time today to be able to manage the thing when you have the money to manage the thing. More question?
You really replace the servers every 1-2 days? Shut down, start up?
Yeah. It's basically about stuff. So basically, we don't do anything about that. We just watch the monitoring to say if it's working or not. Yeah.
How many servers do you make in your own?
I think it's a tricky question because we buy and sell server every time because we are not like stick to a server because it's a fully automated job to set up a new server and to discard the server. It's a fully automated job. So basically what we do is watch all the deals we can do on the hardware part. And if a deal is cool and we have a huge load, we're just buying something. Or maybe if the deal is good, we're just buying and see what's around. And if we don't need an hardware and we have too much free space, or yeah, we're just sitting around. Today, I'm thinking we have, I don't know, really, I know we have like terabytes of RAM and hundreds of CPUs, but I don't know how many physical machines I'm not on the ops team, so basically, what I know is they're doing the trade all the time to make sure it's happening. But what I can do is hundreds Right, yeah.
This public cloud is kind of system like Heroku, similar to Heroku, or
It's kind of like Heroku, but with performances, because we have pretty much performances and able to making huge load traffic. We have node on time redeploy, we monitor your application, so if it fails, we launch it. We make the security update. For example, when there are else bleeds, Heroku send an email 3 days after us saying, please restart your application. What we do at Clever Cloud is sending an email saying, okay, it's managed. It's not your job. We manage more things like that. We are not in containers, you know. Containers can be a security flaw or something we fear the business, big business corporation. So we have all on virtual machines, so it's pretty split. And you know, the guy of Heroku have built a great things. And when I start Clever Cloud, so well, the company just buying by Salesforce, and it was so cool. So I'll never make money, but it was so cool. But the thing is, today, okay, look at the new dashboard. It's all new dashboard, but 6 months after us. Look at the GitHub link. It's what we built 6 months before us. So we built it 6 months before them. So basically, Heroku is something cool because you can hack on it on a startup weekend or hackathon. But what we do is a production-ready stuff. And we are European, you know. It's something it can worth. We are the European company about that.
No, I might have one more question. So there are companies having huge farms of servers running their application, which are CPU intensive, so like thousands of servers maintained for a time. So my question would be, do you think that providers of platforms like you guys can handle this workload? And what kind of a payment model would you propose to the companies?
Yeah.
So that it would be cost effective both for the company coming to you and going to, outsource maintenance for providing for and also to be like this.
to give an example, 2,000 of servers really heavily
Running, running hot because of the fact that their business processes are
Yeah.
highly secure.
Like, really using the server.
CPU especially calculating the stuff.
What we do with this kind of company is, first, we can manage special deal because, in fact, if you're looking on what does Heroku on top of Amazon, they haven't a lot of business decision possibilities because they have on top of Amazon. But we're on top of our own hardware. And basically, we can make deals like, okay, we will install the Clever Cloud on your thousands of servers and managing it remotely. Or maybe we can make deals saying, okay, we can make you special price to manage this kind of thing because the volume will handle all the thing. Public price have been made for handling small to medium projects because at the beginning there is fixed price like support, branding, all this kind of thing. But if a large company coming to us, we say, okay, we can manage this. And the price is not the same because you have to be cost efficient for them and for us. It's always more cost efficient for us to managing large bunch of servers because we have all the technology of managing servers. And we can make a very low margin on top of this kind of deal because there's a large volume of server. So basically, it's a part of the industry like quite complicated to do right now because nobody is on top of the cloud. If you're looking at the numbers, Amazon numbers have been hidden inside the whole Amazon group for years now. And what is going on is nobody knows how many money is making Amazon. And several months ago, the SEC saying, oh, guys, give us a number. And the number is pretty interesting. They're making the exact same revenue than Windows Azure. They are not like the biggest giants in the cloud people think. And this is the way of cloud computing is doing right today. It's a very small market, and we need to industrialize it. And this year will be the real competition about how many the cloud computing can be a real industrialization for this kind of thing. Because company with 2,000 servers are not on top of Amazon today. They are on top of their own infrastructure. So basically, I think it can be a part of the answer. For the people who haven't, I have some special sticker there. And okay, thank you very much for listening one time again.